Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Hi everyone, welcome to HPC News Bytes. I'm Doug Black of Inside HPC, and with me is Shaheen Khan of OrionX.net. When ChatGPT ignited the AI rocket ship 2+ years ago, it pulled huge investments into AI chips and led to what today can be described as the GPU-ASIC War. On one side, we have the established GPU giants led by NVIDIA and AMD, with Intel mostly in the background, but never to be completely discounted. On the other, we have public cloud and hyperscaler behemoths building their own AI chips, which the industry is referring to as AI ASICs. A bit of a curious nomenclature since GPU stands for Graphics Processing Unit, so they are not too general purpose, and the chips that drive the market are data center server chips that do AI and HPC. And ASIC stands for Application-Specific Integrated Circuit, and what the hyperscalers are building look more like GPUs than not. Regardless, building your own GPU or ASIC is not too much of a diversion for hyperscalers. They have been doing that for several years, and today they all have significant development across CPUs, GPUs, DPUs, and many of them also invest heavily in QPUs for quantum computing. We discussed the landscape in episode 100 of the full format at HPC Podcast with Dr. Ian Cutress.
A very informative and popular episode, so please check it out. Among the big players, we have AWS with the Graviton CPU, Inferentia and Trainium AI chips, and the Nitro DPU. Google Cloud with its well-established Tensor Processing Unit, TPU, Microsoft Azure with the Cobalt CPU, Maya AI, Boost DPU, and also an integrated HSM for hardware security module. Oracle is working on X10M, a CPU focused on database applications, and IBM is developing AI chips like the Telum processor used with their mainframes and the North Pole chip focused on efficient inference. And of course, Meta, Facebook, working on what they call the Meta Training and Inference Accelerator, MTIA. And we should also mention Apple's A and M series of chips that have an integrated neural processing unit, NPU, which they also refer to as their neural engine. Apple has not taken these technologies to the data center.
The Information reported this week that Google achieved a chip win with OpenAI. The report quotes an unnamed source to the effect that OpenAI is moving toward Google's Tensor Processing Units, TPUs, to run its AI products. To date, OpenAI has relied on Microsoft, Oracle, and other cloud providers to use NVIDIA GPUs to train and run its AI software. The reported motive for this move is OpenAI's desire to lower its operating costs by using Google. But before we call out NVIDIA for weakening its grip on the AI compute market, we should note its stock has risen about 60% over the past 2+ months.
Google introduced their 7th generation TPUs 2 months ago, with heavy emphasis on scalability to over 9,000 chips in a single pod, better performance for inference, and they mentioned energy efficiency, but the individual chip's energy requirement is not explicitly disclosed yet, and it cannot be too low with those specs. The 8-bit performance of the chip seems to be about half of Blackwell, but memory size and bandwidth and interconnect are all in the Blackwell ballpark. They're lower, but not by a whole lot. That makes for good ratios and helps with scalability, so you could approach the same overall performance with a different approach. Anyway, the story in the Information says OpenAI is already using the Google chip. The TPU is only available as a service on the Google Cloud, so price-performance comparisons become harder. But the story also says Google is attempting to sell its TPUs to cloud computing infrastructure providers. It's not clear if that is just access to Google's capacity or an actual sale of TPU-enabled systems to emerging cloud providers, because it's unlikely that it would be just a chip. As you said, Doug, what's happening can be attributed to the growing competition in the space, but also to pricing and availability, and of course a desire by users to have multiple options, and especially if they're not building their own chip, which OpenAI very well might.
Keeping with this theme, Meta has been developing and testing an in-house AI chip for model training, according to a Reuters report earlier this year, and the company has begun a limited rollout of the chip. As with Google, it's reported that Meta seeks to lower infrastructure costs by reducing its reliance on NVIDIA. Meta is collaborating with TSMC on production of the chip. The test phase follows Meta's first tape-out of the chip, a crucial milestone in silicon development, where an initial design is sent to a chip factory.
Yeah, high stakes everywhere. Meta Facebook has projected expenses between $114 and $119 billion for 2025, with some $65 billion of that dedicated to AI infrastructure. As these projects become more complex, we're also seeing specialists becoming necessary in a co-design capacity and breaking into an already complex supply chain. So maybe that will become standard practice. Case in point is news that the Taiwanese chip design specialist Global Unichip, GUC, is tapped by Meta and Microsoft for work on their ASIC chips and especially packaging. GUC has reported success with TSMC's 3nm and 2nm technologies.
And there was news this week in the publication of The Information that Microsoft's next-generation AI chip, codenamed Braga, is delayed by at least 6 months. Azure Maya, spelled M-A-I-A, is the name of the family of AI chips from Microsoft. Maya 100 was launched in late 2023, and Braga, expected to launch as Maya 200, was slated for 2025, but now will be a 2026 product.
These projects are massive and complex, so it's not too hard to fall behind. And you're in good company if it happens. The chip world is especially unforgiving, but the big players all have the wherewithal to play the long game. Now, the first time I had a product engineering group report to me, and in order to avoid delays, I started out by doing a lot of analysis on why engineering projects get delayed. The top line short answer was management. That was always the ultimate reason, but the next level of reasons usually trace to product strategy and the competitive environment. You'd have to ask and answer questions like, how much should you push the envelope on technical complexities and on how many fronts? Do you have or can you build all the know-how? Do you have all the patents, integration, etc.? Can you find the right staff with the needed skills? Can you keep the right staff and the team sufficiently intact, or will you suffer turnover? Is your supply chain able and ready to deliver? Does the product specification stay fixed, or do you keep changing it, or worse, expanding it? Are any regulatory requirements anticipated and handled? Is your schedule realistic or overly ambitious? Might your competition make a sudden advance or execute better, making your product not as interesting as it would have been? So these are a lot of questions, and they're very hard, and it can lead to delays. There's a framework called Porter's 5 Forces that helps with some of such analysis. It was introduced in 1979 by Michael Porter, a famous Harvard professor, in his book. So go check it out if you're interested in this topic. All right, that's it for this episode. Thank you all for being with us.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.